Okay, so this is lecture number 6, loops. This is one of the more complicated ones in the course. Not because the material is too hard, but the algorithms and the problems that can arise from these structures in any language, any normal language. Do you know brainfuck, the language? Did I show it in your group? Brainfuck. Probably I did. So brainfuck language. Okay. So this is a program in brainfuck. This thing. It's let me zoom in because this is hilarious. So set cell 0 to 8 is this. Then add 4 to cell 1, and this, and so on. So any normal language which is not this one and similar ones will have loops, and they're quite important. And they're, in fairness, the logic behind the loops is easy, but the problems you will see can be very horrible. Okay, so we'll be doing while loops, do while loops, then for loops, for each loops, and then we will talk briefly about operators like break and continue. The one that we'll be using for sure is break, and I'll show you why when we do our games. And just a single example with nested loops. But once you know loops and you have seen them and so on. After that, solving a problem which involves a couple of loops inside one another is only dependent on your logic and the way you think and solve a problem. Okay, so what is a loop? A loop is a statement which repeats an execution of a block. So we already know what a block is. The if statement determined whether we should visit a block or not. So if the condition was true, we visit the block once and then we go out of it. But here, a loop means that we are gonna repeat these blocks as many times as we need. So they can be a finite number of times. For say, I wanna repeat something 5 times, 10 times, 100 times. While is similar to if. So while we have a condition that has to hold, and until that condition holds, it's gonna loop and do the same statements all over again. So here is while and do while. So do while is only very slightly different, but normally you can go from one to another easily, depending on your logic. They work the same way though. So or for each member of a collection. So for each. For each is a really nice loop. I really like it, especially when you do something like enemies in different games. When you just generally, when you have a collection, you can go through every member of it with this loop. And in some cases, it may be impossible or harder to do the for loop, and even slower rather than the for each. So for each needs just a little bit to work and to work fine. To have a for loop, you would normally have to have an indexer. So an indexer is where I can say I want, days. This is always really hard. Days of week. And if I want to access the second day, this is fine. But what happens if I don't have an indexer and I cannot access it this way? Well, in this case, for each is gonna work fine. Okay, then the while loop. So while is executed while a certain condition holds. And let's get straight into the demo. So as I said, I prefer demos to just roll explanations, because this way I believe you are gonna get it easier. Blank solution, thank you. Yeah, it's hard to think and talk and write at the same time, and yeah, but anyways, I hope I'm doing good enough. Alright, so this is loops. Thank you. Someone is paying attention. By the way, consistency with your code and naming and so on is really important for the quality of the code. If I name something first number, then I want the second one to be second number and not number 2, right? So you want to be consistent with your code, which I don't always do, but I am trying my best. So console application, and the first one is while do while. I'll do this together because they're fairly similar, and there is only one small difference between them. Okay, and since I am now sick of this, I'll just copy paste and put it here. While do while. Okay, so how does it work? So we said that it's very, very similar to the if statement in the sense, when in the structure as well. But the difference is that you don't go through the code or the statements just once, but you do it multiple times. So let me show you, just like a simple, let's call it a diagram. So we are gonna be doing a while condition, open, close, and then here we have some statements. Okay, so what happens? Some code here, you don't care what kind of code is in here, you don't care what kind of code is in there. Other statements. Okay, so once the code gets to here, to this line, it's gonna check the condition. If the condition is true, the same with if, we are gonna go in here once, do our statements, and after that it's gonna go back to while. So yeah, it's gonna go back here to the while, check this condition again if true, and then it's gonna go back in, do the statements, go back in, check the condition, and so on. So it's like a loop. This is what is meant by a loop. So it's gonna repeat the condition, it's gonna repeat this block until this condition is true. So if at some point this becomes false, then we're gonna go out of the loop. If it's false the first time, it's not gonna go in as well, right? So it's like an if, but it repeats itself many times. Okay, so what kind of examples do I have for you today? Okay, so we would like to print the numbers from 1 to 10. And this is fairly easy. You can do it with console write line 2, 3, 4, 5, and so on. But what happens if here I put 100? It's going to take you a lot of time, and it's not going to be nice. So right, so you should try to use loops whenever you have some kind of repetition. So here I have to repeat the process of printing the number 10 times, and this is what we will do. So okay, we will need a counter, or some value that is going to change from 1 to 10. So at some point it's going to be 1, then it's going to become 2, then it's going to become 3, and so on up to 10. And for each of these values I would like to do something. So I have the condition. If my counter or number is less than 10, I want to do something with it. Once it's 10, I've done my job, and it's gonna go out of the loop. Okay, so let's do that. So int counter equals, let's start from 0, and then I want to do while tap again. It creates it for you, and I want to say counter less than or equal to 10, and then I want to print just on a single line to save some space. I want to print the counter and the space, so that you know it's fine. Okay, let's run this. And I only get zeros, and this is what should happen, so I'm missing something in here. Increment the counter. Okay, so first let's take a step back, see what's happening. So I'll just press I'll put my breakpoint here and I'll press F5. Okay, so we have our counter, which is here in locals. Okay, so while checks it is true, we do this. Okay, gets back here, counter is still 0, checks it, writes down, checks it, writes down, and so on. So nothing here changes, and at no point of my code this is gonna become bigger than 10, to make it false, and so that I go out of the loop. So this is called an infinite loop right now, because this is always true, and this thing is gonna repeat itself infinitely many times. Okay, so to change this, I need at each step to increase my counter, and now we get from 0 to 10, and this is what we want to do. Okay, so this is a very simple example, but loops are very, very powerful when you want to repeat something, when you don't want to do it by hand, and sometimes this is the only way to go. You can't write everything by hand in your code. Okay, so this is the first example here. Then I wanna do something else. Print the sum of the first 15 numbers. Today I'll be using more hard-coded values, but here if you want to change this number to 10, you can clearly do something like let me just remove that because it's annoying. So int numbers to write or to print equals int dot parse console dot readline, and here instead of 10 I would like to print to whatever number I input, something like 20, and it's still gonna work. Something like 100, something like, I don't know, 2, something like that as well. It's pretty. So yeah, but not to stop the programs, because there are a lot of demos in a single code. I'll just use hard-coded values, but you can change those at any time with this line of code, just to be input from the console. This is now 10. I'll leave it with 10. Print the sum of the first 15 numbers. Okay. To do that, we are gonna need a variable called sum. So int sum, and we should start with 0 because at the beginning we don't have anything to sum. And then we are gonna need a variable which is similar to the counter. It's gonna go from 0 to 15, or from 1 to 15, so that I can put them in the sum. Okay, so we would like int, I don't know, single sum value, and we start from 1. And to make it look prettier, I'll just do the sum of the numbers from 1 to 15 is. Okay, and okay, so let's do our while loop. The condition is gonna be single sum value is less than or equal to 15. Let's make this smaller so that we can keep track. I personally don't know how much is 1 plus 2 plus 3 up to 15. It's easy to calculate, but yeah, so let's put here something like 7. Okay, so this is going to be 7 as well. And right, so what we want to do is increment the sum at each step with this single value. So it's going to be sum plus equals, or sum equals sum plus single sum value. Okay, so this is gonna iterate 7 times, or in this case, yeah, 7 times, and at each step I'll be adding the value there. And there is one thing that I'm missing, which is I know, it's okay, I know. Single sum value plus plus. Okay, right. So finally, I just need to print the value, so sum here. Sorry, 1 to 7. Am I missing something? Oh yes, thank you. And I need to print a couple of new lines. This one is not gonna be on a new line, and I need to print to make it look better. Or I can try something else. I didn't show this in the other lecture. Let me just try this. New string, and then I would like to have dashes, and then 20 times. Let's see if that's gonna work. I'm not sure if that is gonna work. This 20 should be inside, of course. Okay, so now I just need a new line as well, and make this something like 50, and now it looks a little bit better, so I'll be using that. It looks better. Okay, right, we forgot to check the sum. From 1 to 7, is it 28? Okay, I believe you. I'm bad with numbers. Okay, so yeah, no, it sounds weird for a mathematician to be, you know, bad with numbers, but at university, there was a time where I didn't see a single number on the board. It was, you know, all strange letters and signs and so on. Very rarely would you see a number all on the board when you do maths. But anyway, so yeah. Okay, let's do this here again. And what else do we want to do? We want to check if a number is prime. Okay, this is a very standard problem. We'll be doing it with the while loop. So first of all, can you tell me, like, in some language of your choice, how do you check if a number is prime? First of all, do you know what prime is? So prime is when the number is only divisible by itself and 1. Okay, so how do we check this? Yes.
Use counter. Divide the number by the counter. If it's divisible without remainder, it means it's not prime.
Okay, yeah, this is the algorithm that you're saying, which we are gonna run. I just want a simple explanation. How would we check? You know, you were just doing me the algorithm, you know, like step by step. So
increasing value that goes to half the number.
okay, so we check all of the values. We check all of the values from 2, right? Because we shouldn't check 1. All of the values from 2 up to half of the number. And if our original number is divisible by one of them, it's not gonna be prime. Otherwise, it is gonna be. But there is, you know, a quicker way. This is gonna work as well, but we have a quicker way, which is.
I wanted to say that we don't need to go to the half of the number and to the SQF tail.
Okay, so we don't need to check up to half of the number. We can check up to the square root of the number, or the closest value. So yeah, so let's do this. So we need to check if prime number, and this is going to be my variable down below. So let me just do that. Int prime number equals int.parse console.readline. Okay, so we need to check if all values between 2 and prime. We need to check if all values, yeah, between, sometimes words are hard, between 2 and square root of prime number divide prime number. If one does, not prime. If all don't, prime. Okay, so fairly simple. If I have something like 11, is it, so square root of 11 is 3 point something, right? So I should check only 2 and 3. So does 2 divide 11? No. Does 3? No. So it's prime. If I try something like 9, square root of 9 is 3, so I should only check 2 and 3. So 2 does not, 3 divides it, so it's not prime. So it's pretty much that. There is even a better way, but we are going to be using what we have to write, so it's not a good way. Normally you would have to check only the prime numbers up to some value, but here we'll be doing all of them. So if you want to check something bigger like 100, we will check 2, 3, 4, 5, 6, 7, 8, 9 and 10, whereas in practice you would only need to check 2, 3, 5 and 7 to do that, but it pretty much uses what we want to write, so we'll just do all of the numbers up to square root of the number. Okay, and then so we have the prime number. We need a value that is gonna increment, which is gonna be our divisor, and we are gonna start with 2. After that, we are only gonna, you know, we don't need to put it, but it's nice to have. So int max divisor equals math dot sqrt of prime number. So this is going to be the maximum value, and we are always going to want to be below it. Can you tell me why this doesn't work now? Sorry? It's a double. So this is a double, and I need to cast it to int. There are a couple of ways that you can do this. I don't know if we explained this. If I explain this, there is a math.round. In here I can put math.sqrt. Yes, I saw this. And it's not even spelled this way. Math.round of, or you can use, let me just put it this way, or you can use math.round of math sqrt of prime number. You can also use, by the way, I tried this yesterday with converting to int this way, if you remember, and it didn't work in C# for some reason. We can investigate on Sunday why doesn't it work. And there was another way which I cannot remember right now. Oh yeah, there was the convert. So int 32.convert, or was it convert to int 32? Yeah, so convert dot to int 32, and then we want to put math.sqrt and so on. Yes. I don't know. I really don't know. This is so the question is there a difference between parse and convert? Difference between male, okay. Interesting things come up when you search on Google. So is there a difference between parse and convert and C#? Okay, so this is for parse. Okay, yeah, there it is. If you've got a string and you expect it to always be an integer, you'd use int.parse. Okay, so this thing converts it. So if you're collecting input from a user, you would generally use try parse, because that's the thing that I've mentioned, because someone can put something else that you don't want to, and you want to catch if there is an error. Say if you want a number and he inputs a string, you want to catch that error so that your whole program doesn't stop working. Okay, and converter takes an object as its argument, and the guy believes. It invokes in 32.try parse. So one uses the other, and convert doesn't give you this exception, argument no exception. So you can put an empty value, and your code is still gonna work. So that probably means that it uses try parse to do that. But yeah, this is a kind of question for Google. I don't know that much. I don't know anything now. Okay, so right. So yeah, you can use any of these three, but this one is fine in this case. It's a bit simpler. And so we need our while, and our while is gonna say loop this thing until divisor is less than or equal to max divisor. Okay, what do we need to do here? We want to check if a number, if divisor divides prime number. Okay, to do this, we are going to need a Boolean variable. So bool is prime, and we are going to give it a default value of true, and you will see why. Okay, so we want if, why do I do that always? So if prime number divided by divisor is 0, which means that if there is a remainder 0 when dividing by this number, then we would like to change is prime to false. Okay. And what else do I need to do for this, to work? I need to increment the divisor. So divisor plus. Otherwise, we'll be in an infinite loop. Console.writeLine, and is the number is prime, and the answer is prime number. And then I would like to have one which is prime.
You could also break when is prime becomes false.
Yes, this was going to be my next point. Thanks. Okay, so let's put some number 101. Yes, it is prime. 7 is prime. 12 is not. Then 2 is prime. Okay. 1 true, but it's not. Okay. So we need to do that as well. So to work it, for it to work properly, we should check that as well. If prime number less than or equal to 1, wrong number, or error. Okay, but we are also gonna need to change it here, because even if it's 1, this piece of code here is still gonna be evaluated. So we need another boolean, which is gonna be bool is valid prime, and that is gonna be true, and we would like to change it here. So is valid prime is gonna be false. And also here I would like to add this condition. So whenever this is whenever the divisor does not exceed, and also I would like this loop to stop. So it's either the first or the second condition, which is going to be is valid prime. Do I need to write something else? Do I need to do equals true? No, I can leave it this way. So this is something that I didn't say, but we will get to it, I'm sure. So if you have a Boolean expression, you don't need to do this check, equals true. Okay, so now this reads while divisor is less than or equal to max divisor, or our prime is valid. You can see that you can still read it fine. So while this is true, do this. Okay, let's have a look. Now let's put 0. Is 0 prime true? Yeah, I need to set this here to false as well.
It goes in the while.
Sorry?
I think it should be end in the while.
And
It becomes an in this file.
oh yeah, of course, yes, of course. Sorry, my bad. So 22, and then I wanted to check 0 error. You suck. But then it still gives me true, so I should check this as well. So is prime equals false. Okay, and now it works fine. There are other errors that you should catch when you do a game and so on, but for now this is fine. Okay, right. So yes, I wanna debug this code now, and you will see why we can make things a little bit better. So let's get to here. I press F5, and now I have to put a number. So I'll put something like 11, something not too big. Okay, you see now how many variables I have here? No, it's not nice. So what I would like to do is add them in the watch. So I would like to have the is prime, is valid, prime, max divisor, divisor, and prime number. I would like to all of them, or maybe just one of them, add them. Can I not do this? Okay, I can add watch. Right, and we can now keep track of all of these values here. I'm sorry that it's too small, but there is no way for me to make it bigger right now. Okay, so right, so let's see what's happening here. Prime number is 11, divisor is 2, the max one is 3. Is prime is true, is valid, prime is true, and so on. Okay, so let's start. We are checking 11 divided by 2. Well, that's not true. We keep going. Okay, so here this is true as well. It's not divisible by 3, it's fine. And then we jump straight into this sentence. But let me put something different as a value, and I'll show you why. So let's put something like 24, or maybe just 12. Okay, 42, nice number. Okay, so F10. All right, so here we check, and clearly our divisor is 2, so 42% 2 is going to be 0, so we our number is not going to be prime. And this is something that we know, from the first step. But the loop is still going to go on and on and on until we get through all of the values, where in fact we don't need to. So once we find one such number, then this loop can stop, and we don't need to do extra steps to do that. Can you imagine some huge number like 5,000,000,002, and then you will have to go through all of the numbers, which is bad. So to do this, we use break. Okay, break, it means precisely what it says. So breaks the first outer loop. Okay, so we have the while. We've checked here that with the 42 that this is. Let me just debug. So this is going to be 42. Then F10. So now we check it is true, and we know that our number is not prime anymore, so we break, and the loop doesn't go on. Right, so this is very useful. Okay, right. I did go into debugger again. Okay, so that's yeah. I have one more example of this type. So let's do that. So calculate n factorial, and we'll use this same number. So I would have int factorial number equals, first of all, I did this as well yesterday, so n factorial is 1 times 2 times 3 and so on times n, for those of you that don't know. So factorial number, I am gonna do it the same as prime, so that I don't want to, you know, input again. So prime number, and then we're gonna change it up here as well. Okay, right, so I want to do this calculation, and it's pretty much the same as with the sum, but I need to change, you know, just one line probably, or 1 or 2 lines maximum. So let me copy my beautiful separator up here. Let's see how it goes. Beautiful. Okay, so then I want to have int product this time, which is gonna start from 1, because if it starts from 0, if I multiply many times, I'll still be getting 0. And then we need again a counter, which I am just gonna call index, which is gonna go from let's put it from 1. It's gonna go from 1 up to n. Right, so we said that we need loops when something repeats, you know, something increments by 1 or decrements by 1 or 2 and so on. So whenever you have to repeat some process, and here we have to repeat multiplication by some number. Okay, I'll probably need something else, but I'll add it as we go. Okay, so what we need is the index. So we're gonna do this loop while the index is less than or equal to the prime number. Or sorry, the factorial number. Okay, and everything that we need to do is product equals product times index, and after that I would like to increment the index. You always have to do this step, otherwise you'll be in an infinite loop. Okay, and then of course I probably need to print it, so factorial equals equals, and I would like to have product here. Is this gonna work?
No.
I need a second one, yeah, sorry. So yeah, and I should have put it here. So factorial number, is this gonna work now? Okay, let's have a look. Something simple like 5, because I know what I know what 6 is as well, but 5 should be 120. So yeah, there we go. 6 should be 720, and yeah, there it is. It works. It's very similar to the sum as well, as you saw. The only difference is that the sum here we started with 0 because we are adding numbers, and here we have to start with 1 because you know, it's not cool when you multiply by 0. Okay, I want to make a point about infinite loops. This is an infinite loop, while true. And even though, you know, we made it so there was an infinite loop a couple of times, and we didn't want that. In some cases, we would actually like to have an infinite loop and break it with this break operator under certain conditions. And this is what we are going to be doing all our console games with. So the example here of why, imagine if you start a game at home on your PC or, you know, phone and so on, and if you don't do anything, if you don't touch anything, it's just gonna stay there, right? It's not gonna exit. It's not gonna do anything. It's just gonna stand there for, you know, infinity. Quotes. And right, so it is gonna, you know, exit the game if you tell it to. It's gonna do only the things that you tell it to. But if you don't do anything, you know, it's not gonna exit and so on. So here, in this infinite loop, we'll be doing our games, and every single game is gonna have a while true loop that is just infinite. And to stop it, we can have, you know, game over conditions, or, you know, health less than 0, for example. You know, when something happens which is gonna end our game, this is when we are actually gonna want to exit this loop. So this is gonna be done with break. Okay, so but if none of these happen, the game is gonna go on, right? So our loop is gonna go on and on and on. And in this while loop, this is called the game loop if you're doing a game. This is where we'll be doing all of our logic and drawing and so on. Well, drawing, you know, again in quotes, but yeah. Okay, so let me comment that as well. And another quick point about do while. Okay, what is the difference between while and do while? And I would like to probably go back here. So while loop, and here I would like to do a do while loop, and I'm gonna copy all of this. This thing I have to put here, and here we have do. So this is, you know, pretty much the same as with the while loop. The only difference is that the loop is gonna evaluate the statements at least once, right? It's even the same when you think about it in English. So the first one starts with the while, and you have the condition there. But the do here, it's gonna go inside at least once, and it's gonna check the statement afterwards. Okay, here we only we don't go into the loop unless the condition is true, but with do while we are guaranteed to go at least once. So let me do you know, a very, you know, brief and quick example of this. So let's say while, and then I'm gonna put false here. Sorry, someone said something, or no? Okay, so while false, and then I want to do console right line, this is never executed. Okay, and if I do the same thing with the do, console right line, so this is never executed in the while loop, and this is now executed in the do while loop. Okay, right, and then I have to put my condition afterwards, which is false. Okay, so we would expect this never. By the way, you have to end it with a semicolon. Okay, so it even tells me unreachable code. So this code is not gonna be executed at all ever, because the condition is false, and it's not gonna go into the loop. It's gonna go straight into the next one. But this one, even though the condition is false, this is going to be executed precisely once. So we can see that. Let's put 5. This is now executed in the do while loop, and I can even debug, you know, very, very quickly. Let's put a 5. Okay, so I'll have another breakpoint. I think if I press F5, it's gonna go to the next breakpoint. No, or F6. Was it F6? I don't know. There was a way to go to the next breakpoint. Step into, step over, step out, code map. Show next statement. Okay, I don't remember this. It was probably something useful to be said. But yeah. Okay, so false. It's gonna skip it, but the do is gonna, you know, do this just once. Check the statement and then go out of it as well. Okay, that's pretty much everything I can think of for while loops. Do you have any questions? Everything is absolutely clear. Good. We did that as well, and after the break we'll continue with 4. Okay, so next up we have the for loop, which is the one that you'll be using the most, I think. And it's very popular. It's not that easy to read like the other one. So the while was very easy to read. The ifs were very easy to read as well. This one not so much, but once you get used to it, and in most cases you will have to use just the very basic for loop. So yeah, let's go straight into the demo. This is going to be a bit boring, probably, because I'll be rewriting all of this. I mean, a lot faster, but all of these problems here I'll be rewriting them with for loops, just so that we see the difference. Okay, so this is 2 for loops. For loops, and I need to copy this, change this. Okay, right, so let's just do a description of for. I need 4 lines to do that. Okay, so we have 4. We'll see in a bit what we have in it, and of course we have statements that we have to repeat. Okay, so the for is a bit different in structure. There are 3, let's call them arguments that you have to put in. With the while, it's just a single one, which is a Boolean expression that evaluates either to true or false. This one is a bit more, a bit different. So first we have initialization. Okay, sorry. Okay, right, then I put semicolon. Here we have conditions, and here we have update. Okay, and now I'll explain which one does what. So initialization, here you put variables, you initialize them, variables that you are going to use only within the loop. So this is for example, here with the while, we have counter, we had, what did we have here? We have indexes, we have basically these values here, the divisor and so on. So all of these that you were just going to use inside the loop, these are the ones that you should initialize here in the first field. So, okay, then we have conditions. This is pretty much the same. You can have different conditions which evaluate either to true or false, and they're checked at each step. So the same as with while. And here you have update, something which happens after every single iteration of the for loop. Okay, it's kind of hard to explain it properly, but with some examples you will get used to it. So. Okay, so how does it work? So when we enter the for loop for the first time, we initialize what we want to use. This is done only once. Only once. Okay, then we check the conditions. After that, we go straight into here. we do all of the statements, then it goes to update and checks conditions again. Okay, and this goes on and on and on until this thing becomes false. So if this is true, go in here, update conditions, go in here, update, and so on. You will see it now. So I'll be rewriting the code for while loops, because you already know how they work, or at least you've thought about how they work. So let's do that. So let's start with numbers from 1 to 10. Just print numbers from 1 to 10. Okay, so you write 4, tap, and it creates quite a lot of things. So this is the index, which it's fine if you call it I. Okay, here you don't have to have a descriptive name. It just says here as well, I don't know if you can see this, but it says index. So this is the value that will be changing. It doesn't need to be just one. You can initialize many things here, but the most normal for loop initializes just one value. So we want to print the numbers from 1 up to 10. And we would like also the equals to 10. Right, so this is pretty much it. So we have the I, which starts from 1. We would like it to go up to 10. So this is a Boolean expression which is either evaluated to true or false. And at each step I would like to increment by 1. So let's do that. And then I'll just print I and some space, you know. Let's see what happens. And I forgot this time to do what you have to do every time. So okay, there they are. I want to drop the line. There it is. Okay, fine. What happens if I want to print just the even numbers? Okay, so I would have to start with 0. So I want to print 0, 2, 4, 6, 8, and so on, up to 10. And instead of adding 1 at each step, so this is the update, the update at each iteration of the loop. So instead of here doing I plus, which is going to add just 1, I can do I plus equals 2. And this is going to add 2 at each step. Okay, I can do more interesting things as well. I can do just, you know, multiples of 2 or powers of 2. This one is not going to work now because I started with 0. So at each point it multiplies by 2 and so on. So 0 times 2 is 0, and it's going to do that over and over again. So you can do an infinite loop with 4 as well. That's not a problem. But if I start with 1, we're going to print 1, 2, 4, and 8. And if I increase this number to, say, something bigger, it's going to print all of the powers of 2 up to that number. Okay, so let's change this back to the way it was. So plus, Control F5. Okay, and let's just debug and see how this works. So F10. So okay, so first we initialize. Up to this point, we did not have the I, but once we are at this step, we have it. Okay, so goes I equals 1. Then we check if the condition is true. In this case, it is true. And here, if I zoom in, it even says true. You probably can't see it. Let me try that again. Okay, so believe me, here it says true. Right down there under the I. Okay, right, so if I go on, now we get into the loop, we print, we can see the 1 here, and then we update. So this is called after each end of the loop. Okay, then we check it again, write, update, check, write, update, and so on. This is going to be done 10 times. We initialize only once what we need to use. Okay. And now it ends and it's all done. Okay, so let's do sum. And I want to copy that cool separator that I did. Where are you? There. Okay, now I want to do the sum. So for sum from 1 to, let's call it 11, less than or equals to. And also, can I put my sum here? No one knows? Because I said initialize means that those are things that we'll just be using inside the loop. No, because
Inside the loop.
okay, and the sum that we want to have is gonna be, you know, outside of the loop that we're gonna be printing. So I need to do that here again. So in sum equals 0, and it's as simple as that. Sum plus equals I, or sum equals sum plus I. This is what I prefer. And then of course I need to print the sum. Let's have a look. Sum from 1 to 7 was 66. Okay, so let's have a look. 66, and let's put something in here. So the sum from 1 to 11 is, and then comma. Okay, so this thing seems simpler, right? You know, it's hard to understand what is going on here, probably because there are 3 things that you have to put in. But once you get used to it, you know, it shortens the amount of code that you have to write. So with while you are a bit more flexible, and it's easier to read, but you can forget to update your values and so on. So you can make mistakes, but here it's very hard to do so. I have a question. Can I put this thing in here?
Without
Yes?
it runs it even after the final.
Yes, it runs it even after. So if I want to put this here, you know, because this is done at each step, okay, I just need to change this to 10. And we got 65 and not 66 for some reason.
It didn't do this with
It
one.
just adds the last one twice.
It didn't do this with one.
Okay, I wanna do, I just wanna try this because this may work. Oh yeah, I have to start from 0 as well. But let's check this. So this thing works as well now. The reason is that the order matters, right? So if I first add and then increment I, then this is clearly gonna be different if I do it the other way around. So you can do any kind of updates here, but normally you should only leave this I++. Now there are some weird cases and so on, but I never had to use something different from, you know, this normal structure. But here, if I wanna, yes, of course, I'll put it. But here, if I wanna initialize, you know, something else, and something like another number equals 3, I can do that as well, and it's gonna initialize all of them in order, everything that I will need for my loop. But outside of the loop, these will not be available. So let's have a look. So we have I, it's there, we have int I, but if I try to print it here, you know, just like that, just to see what happens. I get an error, and it says I does not exist in the current context. Okay, so it's only available in here. I can print it here though. So if I want to just put I there, this is gonna work. Okay, so this is the I, which goes from 1 to 10, and the sum here is down there. Okay, what else? What else? That's pretty much it for this specific example. Okay, we can do the same with the product, right? Int product or factorial equals 1, and it's pretty much the same loop. So I from 1 up to, let's do our favorite 6, and I need to do factorial equals factorial times I, and that's gonna be fine, and I can print. So I want to have this, put it also the product from 1 to 6, put it here, and I'm going to print the product is factorial. Okay, the product is 720, is the same thing that we agreed on. Okay, so this is a lot quicker now, what we are doing. Let's do the prime numbers as well. Prime numbers. Okay, so it's pretty much the same. Let's do int prime number equals okay, after that I would need the so-called divisor is the thing that I'll be changing, so I can initialize that in the for loop, but I can have max divisor, which is we said int math.sqrt of prime number. Okay, and just oh yeah, I need the boolean as well, so bool is prime, thank you, equals true, and for tap I need to go this time I need to start from 2 and less than or equal to max divisor, and here I need again if prime number percentage I this time, because this is what I'm changing. I can also do, you know, here I can write divisor and it's gonna work as well, but normally it's good to use I, K, L and so on. It's when you use those, it's clear for everyone that you're using an index that increments. Okay, so prime number percentage I is 0, then what we want to do is prime equals false, and also I would like to break. It works the same way as with the while loop. So once I go into the if, this loop is gonna break. This break is gonna stop the usage of for, and we are gonna go straight out of the loop, which is not here right now. So we are gonna go. So it's gonna stop this and go outside of the loop, which is right here. Okay, and right, so after that, just, you know, put, I would like to have my separator right here, and I would like to have is the number prime, and I would like to have prime number and then is prime. Seven, true. 4, false. 111, false, because it's divisible by 3. And 0, it still says true. We can fix it the same way, but let's not be bothered this time, so this thing works. Okay, what else is there? So we did the prime numbers, we did that as well. Okay, some new ones. I would like to have the product of numbers between two values, so between m and n. Okay, so calculate product between n and m. So here I will have int n equals, let's say from 5, int m equals 11, and int product equals 1. And then I just need my for loop. For I is gonna, so I need to do 5 times 6 times 7 and so on. So I is gonna start from 5, it's gonna end at, oh yeah, I just need to put n here. N to m, and I just need to do product equals product times I, and then print product. So the product between and so between n and m is, yeah, I'll fix that, I saw that, is this, and I would like n, m, and then product. So between 5 and 11, I trust it, or maybe I shouldn't. Is this correct? Yes. Did you calculate it in your mind? So let's do calculator. What? So 5 times 6 times 7 times 8 times 9 times 10 times 11. Okay, good. It works. Right. What else? What else do I have to show? We did this, we did this, we did this as well. And okay. Now I would like to do something a bit more weird. So I would like to have sum of all powers of 2. Okay, so this is going to be 2 plus 4 plus 8 and so on, and I'll do it in a single loop, meaning you see what I mean. So I'm going to start with I from 1, and then I'm also going to want sum which is going to start from 1 for some reason. We'll see why. And then I would like to have I to be less than or equal to 1025. Then since these are powers of 2, so the I is going to be 1, 2, 4 and so on, I need to multiply it by 2 at each step. What? Oh yeah, I already have some, so sum powers of 2. Okay, so I has to be multiplied by 2 at each step, and I also want to have sum equals sum plus I. Oh yes, thank you. Sum powers of 2, sum powers of 2. Okay, and at each step I would like to see what is going on. So I equals this, and then sum equals this. Then I, and then sum. Sum powers, thanks. And there we go. So I increments and is multiplied by 2 at each step, and then we add it to the sum at each step as well. We started from 1 because I is the first thing that we update. So we first multiply by 2, and then we add it, and this way we will not be including the original one. So again, there it is. Okay, the point here was that you can make more complicated for loops if you want to or if you need, but even in this case you really don't need to. Okay, this can be done also with a simple for loop which starts from I from 1 to 10, and I wouldn't need to put this sum here and this sum here as well. So just try to keep it simple, and all of the complicated logic just put inside the loop, because you don't need anything complicated here, because when I see something like this I think, who the hell wrote this? And it's not nice to look at. Okay, last example with for. We would like to sum all odd numbers which are not divisible by 7. Okay, for some reason this is to check what the operator, so example for the continue operator. Okay, so we already know what break does, and we would like to see what the other one continue does. And to do this, we're just gonna int sum odd numbers equals 0. For, okay, so let's say that I want to sum all odd numbers which start from 1 and end in, let's start with a 9 first. Okay, and I would like to increment I by 2 because I'm only interested in the odd number. So I plus equals 2. Okay, so how to do this? First, I would like to check if I%7 equals 0, means if it's divisible by 7, I am not going to want to put it into the sum. Instead, I'll just be writing continue here, and after that I'll be doing the sum. So sum equals sum odd numbers equals sum odd numbers plus I. And console write line, and I needed to copy this line. I'll put it here as well, and I'll put it here as well, and here. Okay, right, so I just want to print the sum. So the sum of all odd numbers between 1 and 9 not divisible by 2 is, not divisible by 7 is, I can't do that now, can I? And we just do sum odd numbers. So what is this gonna be? I really can't do it in my mind. So 1 plus 3 plus 5 plus 9, 18. Okay, good. Okay, so let's see. Okay, we got 18, but we didn't explain how this works. And it's probably best to just debug, just so that you learn how to do this. Okay, I wanna press F5. I need to put in some number here so that we go on. Okay, so everything is fine up to here. We start with 1. It's not, so we just add it in the sum. We go back. Now I is 3. Do I have I here? I don't have I here, so let's just add it. I just need I. And then I would also like to have this sum. Okay, so yeah. Now, can you see this, by the way? Okay, so the sum is 1. I is now 3 because I added 2. This is not true, so we add it again, so this now becomes 4 here. I add 2 again, now I is 5. This is wrong, so we don't do anything. And now I is 7, so we go into the if, and by writing continue, everything else after this line of code is not going to be evaluated. So once this is true, this thing is not going to be evaluated, but the program will instead just go back straight to here. So if you have some other statements here, by writing continue, these are not going to be evaluated. We are just going to go back to the 4 and increment I. And this could save you, a lot of steps if you don't want to do them somewhere in your code. Again, I rarely had the need to use this. This is why I'll be mentioning it with. So just these examples, so that it's there and how it works. But we're not going to go into that much detail. Okay, right, so let's go with the for each loop. Are there any questions about this? Should be fairly simple. Once you understand what's going on here, it's a lot easier to write all of this code here. And we did it a lot quicker as well, rather than with the while loops. A lot less room for error as well. Okay, so for each loop. We said that it iterates over the members of a collection. No one laughed at my joke. For each beer in beer's drink. Okay, so first of all, we don't know what a collection is, so I have to give an example with something that we haven't done yet. But let me try and do that. So okay, so let's say that we have a variable which is string. No. String, some variable s is, whatever. Okay, so the program, or you can think of the way this works is that we have a single cell, and this is our variable s. Okay, I can make something which is an array of similar variables, which you can think of as a list of variables with the same type. So here I can have, instead of just this one s, which is just one, I can have multiple cells with different values, but which I write the same way. So let's do those to be 7. And the way you write this is string days of week. Imagine that this is on the same line. I have to, sorry, yeah, this is not the way you write it. So string, this means that it's a collection, it's an array. Days of week, and now I can write equals, and then I can do Monday, Tuesday, and so on. Okay, so what this is gonna do is it is gonna create a single structure in the memory, which is filled with strings. So each one of these is a separate string value. There is the same as this one, but 7 of them. And if I want to access, say, Monday, this happens with string of 0. Okay, if I want to access, say, Friday, this is going to be string of 4, because we always start counting from 0. This is something that you should get used to. But okay, so this is just very brief. We'll have a separate lecture for arrays, and we'll be using a lot of them. This is just for you to show a simple example with it. So here I'll do the for each loop. Number 3, for each. have you all seen this loop for each? Is there anyone who hasn't? Okay, so it'll be useful to more of you. So for each. I think it's one word. I'm not sure. For each. Okay, so let's have an array. It's the same example that I gave. So days of the week, and this is gonna be Monday, and I'll just copy that. So Tuesday, Wednesday, 4, 5, 6, 7. Tuesday, Wednesday. Let me put the enter here. Wednesday, Thursday, Friday, Saturday, and then Sunday. And I would like to put the semicolon in the end. So what this thing does is exactly what I've shown you. So we have this, array which has 7 values, which are the days, basically. And now if I wanna print some of them, just say days of the week of 5. It should print Saturday. There we go. Okay, so the point of the for each loop is that it's relatively simple, easy to use. You don't need to do a for loop for this. So if you want to print it with for, I would like to start from 0 up to days of week dot length. This means how many values are there. And here I have to do console right line and then days of week of I. So when I is 0, I am going to print days of week of 0, which is going to be Monday. Then I is 1, I'm going to print Tuesday and so on. Okay, yeah, this works. Okay, you can do it this way, but instead I want to do it with for each. So you write for each, tap, and some interesting things here happen. So without getting into too much explanation, here I define the name of each member of the collection that I'll be using. So for each day in days of the week, I would like to print it on the console. Okay, it's what it does is exactly what it says, and this is why I like this this loop quite a lot. So for each day in days of the week, do this. No, for each of them, and this way you may not even know how many of them are there. It just goes through all of them. Talking about this var, so this day is a new variable. If you see, I have not initialized it anywhere, and this is the place to do it. So this var just initializes day. Why is it var? Because clearly the variable here is going to be the same as the type here, which is clearly string. It's the same if I write string here, or just leave it as var. But normally, if you do for each, it starts with var on its own, so you don't really have to worry about it that much. Even if it's something weird like dictionary of int and string, some weird type that we have not seen now, even then it's gonna guess what this item has to be in this collection. So okay. Right, and this thing works. Okay, so can you tell me why this is some? I did say it at the beginning of the lecture. I just want to check if you were listening. Can you tell me why this is sometimes better than the for loop? And there are a couple of reasons. I showed you and I said a couple of them. So why could the for each loop be better than the for loop? Because sometimes the for loop is slower. I don't think it's slower. We can check this on Sunday. But if you do your conditions right and so on, in the for loop it's gonna run with the same speed because it pretty much does the same thing. So yes,
This one can go infinite.
this one cannot go infinite. This is a good reason. Yeah, I didn't know this and I didn't think so. Yeah, I knew this but I didn't think of this. So reasons why for each is better. So it cannot be an infinite loop, right? Because you cannot create an infinite collection. You would run out of memory at some point. Okay, others. Okay, I said one like 2 minutes ago when I was writing the for loop, and I was. You do not need to know how big the collection is. Okay, I said something else. It was again now maybe 3 minutes ago.
Better for reading.
Easier to read, yes. And 4, you may not have an indexer. So indexer is this thing where I said that you can do days of week of 1, days of week of 2, days of week of 3, and so on. So you wouldn't have the index in the for loop which would iterate over them. Okay, some data types don't have it. I mean, I think some of the basic ones as well, they don't have it. Yes. You may not be able to use an indexer. So in this case, I can say days of week of 1, but there may be a collection where I cannot do that if it's not defined. So this is the point. You may not always have it, and there may be something else, but I think this is pretty good. So yeah, also it is a lot more abstract, and this follows from the previous one from 4. So if you don't have an indexer, this means that your collection is a little bit more generic. And once we go to data classes, I believe they were called in C#, so different types of collections and lists and iLists and so on. You will see what I mean there. So to use the for loop, you would need a specific type of structure, and for each you need another one which is a lot more abstract, and you may not have an indexer and other things in it as well. And this really is quite handy sometimes. So say that you are making a game where you generate new mines at each step. So some of them die, some of them are born again, and it may be hard to keep track of how many mines you have. But with this for each loop, I really don't need to know their number, right? I just need to go through all of them and see if it's dead, just remove it or something like that, which enables you to use something more lightweight than an array, maybe some different structure and so on. But we'll be talking about this in a later course. Just get used to this also because it's quite cool and quite useful as well. Okay, any question about for each? Okay, nested loops. This is going to be the last short demo of today. Let me go here, create a new project, which is going to be for nested loops. Okay, here I need to change this, and here I want to change this as well. Right. So the problem that we will solve, this is I'm not gonna explain what it is, how it works, and so on. Just very very briefly, nested loops is when you have a loop within a loop. So the first thing that's gonna evaluate is the inner loop, and then it's gonna go out to the outer loop, and so on. Instead, I would just like to do an example and leave you to bash your heads with the homework. So for this lecture specifically, the homework is probably a lot more important than you being here and listening, because you only learn this by doing the code. So we would like to create the following triangle. Okay, one without. So the question is how I do this. So I press a couple of enters, then I hold the Alt Shift, and with the mouse, with the click, I drag down however many rows I want, and then I just write whatever I need to write. So if I want to write something like console.writeLine, it's gonna write it everywhere. Yeah. It's cool when you want to change, some parts of your code on every single line or something like that. It's cool to have. So I hold the Alt. Okay, and actually to make this easier, I'll just print the one here because it's going to be everywhere anyways. So this is the triangle that I wanna print. And this one I'm too lazy. Okay, right, so this is what we want to do, and it's fairly simple. We just need to notice a couple of things. Okay, so we have 6 rows in this case. The following triangle for different values of n. In this case, n equals 6, which means that we have 6 rows. But I want to be able to do it automatically, for all of the values of n, possible. Okay, so right. So first of all, we're gonna be doing this with for loops. So we have some repetition, we have lines that repeat, and so on. So first of all, we'll have a loop which is gonna deal with the number of lines, right? So we have 6 lines. So clearly, I have to have 4 iterations of a for loop. So let's start with that straight away. Int.parse console.readLine. Okay, and just a for loop which is gonna be from 0 to n. So if I put from 0 to less than n, the number of steps are gonna be n, and it's the same thing if I write it this way. It's gonna be the same number of steps, but the I is just gonna be not from 0 to n minus 1, but it's gonna be from 1 to n. So it doesn't matter. You should get used to it anyway. So starting from 0. Okay, so instead of I here, I would like to change this to row, which row, because these are the rows that I'll be using. And then for each of these, if you notice that the number of numbers I have is equal to the number of rows, which for this reason I am going to put to 1, because you may get confused otherwise. So this is the first row, this is the second, the third, and so on. And we notice that for each of these rows we have the same number of numbers as the row. So here, this is row 1, we have 1 number. This is row 2, we have 2 numbers. Row 3, we have 3, and so on. So this again is some kind of repetition within the repetition. So we need a for loop within the for loop. So I'll be writing again 4. This is going to be the column, or I'll just rename it to number. Right, and we see that the number on each single row always starts from 1 and goes to row. Okay, so this is row number 3, and 1, 2, 3, this is going to stop there. So less than or equal to 3. Row, yeah, sorry. Yeah, because I was talking about 3, sorry. Okay, so then we have, I need to print it. And then, number. Let's run it, see what happens. Let's press 6. Okay, so it does something, but not exactly what we want. And first of all, I need to get rid of this line. Clearly, let's see what happens now. Okay, it prints them, it seems that it prints them also. We have 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. But after each row, I would like to add a new line as well, to make it look like a proper triangle. So every time this inner loop finishes, this means that I have ended my row, and I've written all of the numbers for the specific row. And after that happens, we're going to put a new line. We're going to increase the row and do that all over again, writing the numbers. So 6, good, 20, even better. Okay, if you don't understand this now, if this is something new, please do your homework, and you will be fine with it. So this thing is learned with practice. No matter how well I explain it, and I'm trying really hard, if you don't do it yourselves at home, just think about it for an hour, then you're probably not gonna be able to learn it. Okay. Favorite part, homework. So again, I cannot stress on this enough. This homework is bigger, and so like from 1 up to 5, 6, they're pretty straightforward. 7 is not hard as well, and then after that you may need to think a little bit more. And probably the hardest thing is this last problem. So you have to do the spiral, where you input a number and it goes around until there is nowhere to go. Has anyone done this? Okay, I'm sure, even though you've done it, I'm sure that if you have to do it now, you wouldn't be able to write it straight away on top of your head. Sorry? Okay, you may use whatever you want, but you're not gonna learn it. So, okay. Right. References again, and then questions. Questions? Anyone? No questions at all. You wanna go home? Okay.